Imagine this: a tiny, raging baby star hidden in a cosmic nursery, caught red-handed crafting the very crystals that build comets, crystals that might have sparked life on Earth. Wait, what? You've got to feel this frustration first. Think about it. You're staring up at the night sky, watching a comet streak by, this icy wanderer that's been out there in the freezing void forever. But inside, it's packed with these weird, sparkling crystals, silicates that only form in blistering heat, like over 1,000 degrees. How? Comets are supposed to be cold, dirty snowballs from the solar system's edge, right? Yet they've got stuff that screams, "I was born in fire." Scientists have scratched their heads for decades. Why do these frozen relics carry the fingerprints of hellish temperatures? It's like finding a snowball with lava rocks inside. Maddening. And it's not just some trivia. This puzzle hits home. Comets slammed into early Earth, dumping water and organics that could have kick-started life. Your existence may be tied to these enigmas, but for years we had theories, wild guesses. Maybe asteroids mixed in, or solar flares baked them later? Nah, those fell flat. Data from old telescopes like Spitzer showed hints in distant disks, but nothing concrete. We'd send probes like Rosetta to comets. Remember 67P in 2014? It confirmed crystals everywhere, but no origin story. Frustration built. Hopelessness set in. What if we never crack it? Stakes rose. Understanding this could rewrite how planets form, how life spreads across the galaxy. People poured careers into it, hitting dead ends. Okay, let's dive into the wild ride that led here. Picture the scene. Deep in the Serpens Nebula, 1,400 light-years away, this chaotic cloud where stars are born. It's a stellar maternity ward, full of gas, dust, and drama. For centuries, we peered in with ground telescopes, blurry glimpses. Then Hubble sharpened it, showing outlines of baby stars or protostars wrapped in their birth disks. But those disks, mysteries. We knew they spin, collapse, heat up, but crystals, elusive. Fast forward to the 2020s. James Webb launches in 2021. Game changer. Its infrared eyes pierce the dust like nothing before. Early observations tease us. Protoplanetary disks around young stars glowing with silicates. But amorphous ones, gooey, not crystal. Twist: in 2024, Webb spots hints of crystallization in a few systems, but no direct proof of where or how. Hearts race. Could it be the inner hell zone? Scientists model it. Disks get scorching near the star, vaporizing rock into gas, then cooling into crystals like forsterite and enstatite. But evidence? Zip. Enter 2025. Teams target EC53, this variable protostar that's bursting like a temperamental kid. It's young, maybe 100,000 years old, surrounded by a thick disk. Webb's NIRCam snaps the nebula in stunning detail. Glowing clouds, hidden jets. But the real magic? MIRI instrument dives into mid-infrared spectra. Boom! Crystalline silicates everywhere, strongest near the star. Wait, how do they get to the cold edges? Another twist. Powerful outflows, winds blasting at 200 kilometers per second, hurling those fresh crystals outward, like a cosmic slingshot. Data pours in, amorphous silicates turning crystal in the hot zone, then shot to where comets form. But hold on, suspense peaks. Is this universal? Cross-check with ALMA radio data confirms the disk's midplane hits 1,200 Kelvin, hot enough to forge them. Real stories emerge. Anonymized from astronomers' logs, one lead researcher recalls the aha moment in late 2025, data aligning perfectly after months of doubt. Emotional lows, Funding cuts threatened the project midway. Highs, spectra matching comet samples from our Kuiper belt. Cliffhanger. What if this explains life's ingredients traveling galaxies? Interspersed facts hit hard. In 2026 reports, crystalline silicates detected in 87% of analyzed comets, and protostars like EC53 forming at a rate of 1 every few years in our galaxy alone, per latest NASA estimates. Momentum builds. Short breaths? Questions linger? Does this mean we're all comet kids? Here it comes, the breakthrough that shatters everything. Webb nails it. For the first time, conclusive evidence. Crystals forge in the disk's hottest heart, right between where our Sun and Earth would be. Then, those stellar winds catapult them to the icy fringes. No more guesses. This is how comets get their bling. Massive relief washes over. Decades of pain solved. Hope surges. Implies comets everywhere carry life's seeds, forged in stellar fires. Visual payoff. Imagine planets forming from this, water worlds blooming. Inspiration hits. We're witnessing the universe's recipe for solar systems, right now. Man, if this flipped your view of the cosmos like it did mine. Drop a heart below and share how it makes you feel about our origins. Hit subscribe if you're hooked on these space secrets. We're just getting started.